Hi, my name's Gabe. For this problem, we're asked to find the partial fractions decomposition of x divided by 16x to the fourth minus 1. Let's begin by factoring the denominator. So we can write this as x divided by, well, let's begin by rewriting 16x to the fourth as the quantity 2x raised to the fourth minus 1. Now here, our denominator is a difference of squares, so we can write our denominator as 2x squared minus 1 times 2x squared plus 1. Now again, here we have a difference of squares, so our rational function, or our rational expression, becomes 2x minus 1 times 2x plus 1 times 4x squared plus 1. Now since 4x squared plus 1 cannot factor any further, our denominator is fully factored. And here what we have is we have two distinct linear factors and a distinct quadratic factor. So our partial fractions decomposition will look like a divided by 2x minus 1 plus b divided by 2x plus 1 plus cx plus d divided by 4x squared plus 1. So what we have is we have our original expression, x divided by 16x to the fourth minus 1, and we want to write this in the form a divided by 2x minus 1 plus b divided by 2x plus 1 plus cx plus d, all divided by 4x squared plus 1. Now here, what we want to note is that we already factored the 16x to the fourth minus 1. And we know that this factors into 2x minus 1 times 2x plus 1 times 4x squared plus 1. So at this stage, we can multiply both sides of this equation by the least common denominator, which is 2x minus 1 times 2x plus 1 times 4x squared plus 1. And what this leaves us with is x is equal to a times 2x plus 1 times 4x squared plus 1 plus b times 2x minus 1 times 4x squared plus 1 plus cx plus d, all times 2x minus 1 times 2x plus 1. Now here, we want to choose convenient values of x that will allow us to solve for a, b, c, and d. So let's begin by letting x equal negative 1/2. So if we let x equal negative 1/2, we'll substitute negative 1/2 for all of our x values, and we'll have negative 1/2 is equal to a times 2 times negative 1/2 plus 1 times 4 times negative 1/2 squared plus 1 plus b times 2 times negative 1/2 minus 1 times 4 times negative 1/2 squared plus 1 plus c times negative 1/2 plus d times 2 times negative 1/2 minus 1 times 2 times negative 1/2 plus 1. So what we end up with here is we end up with negative 1/2 is equal to a times negative 1 plus 1. So this term cancels and becomes 0, plus b times negative 1 minus 1, which is a negative 2. Here we have 4 times negative 1/2 squared, which would be 4 times 1/4, or 1 plus 1. So b times negative 2 times 2. And then we have plus c times negative 1/2 plus d. And here we have a 2 times the negative 1/2, which is negative 1 plus 1 is 0. So this term cancels. So what we're left with is we're left with the equation negative 1/2 equals negative 4b. And here we can solve for b by dividing each side of the equation by negative 4. And we're left with b is equal to 1/8. Next, we can let x equal 1/2. And here, what we'll have is we'll have 1/2 is equal to a times 2 also times 2 plus b times 2 times 1/2, which is 1 minus 1. So this whole term cancels. Plus c times 1/2 plus d times 2 times 1/2, which is 1 minus 1, which is 0. So this whole term cancels. So what we're left with is 1/2 equals 4a. Solving for a by dividing each side of the equation by 4, we find that a is equal to 1/8. Now at this stage, we've run out of convenient values of x to substitute to make things cancel. So let's try letting x equal 0. So substituting 0 in for x, we'll have 0 equals a times 1 times 1 plus b times negative 1 times 1. So we'll be adding a negative b. Plus, here we said x is 0, so we'll have d times negative 1 times 1. So we'll be subtracting a d or adding negative d. And we already found that a is equal to 1/8. So here we can substitute a equals 1/8 in here for a. And we know that b is also equal to 1/8. So we can substitute 1/8 in for b. And what we have is we have 0 is equal to 1/8 minus 1/8 minus d. So simplifying, we have 0 equals negative d, or d equals 0. Finally, we can choose any value that we'd like to solve for c. So let's choose x equals 1. So substituting x equals 1, we have 1 is equal to 1/8 times 3 times 5 plus 1/8 times 1 times 5 plus c times 1 and d we said was 0. And we're multiplying this by 1 and by 3. So what we have here is we have 1 is equal to 15/8 plus 5/8 plus 3c. So 15/8 and 5/8 is 20/8. So this equation will simplify to 1 is equal to 20/8 plus 3c. So here, 20/8 simplifies to 5/2, so our equation becomes 1 is equal to 5/2 plus 3c. So we can subtract 5/2 from both sides of our equation, which leaves us with negative 3/2 is equal to 3c. And dividing each side by 3, we find that c is equal to negative 1/2. So here we have our values for b, a, d, and c. So our partial fractions decomposition then is 1/8 divided by 2x minus 1 plus 1/8 divided by 2x plus 1 plus c we found to be negative 1/2. So it's negative 1/2 times x. And d we found to be 0. So we have negative 1/2 x divided by 4 times x squared plus 1. Now we can stop here, or we can take this a step further, and we can rewrite this as 1 divided by 16x minus 8 plus 1 divided by 16x plus 8 minus x divided by 8x squared plus 2. So there is the partial fractions decomposition of x divided by 16x to the 4th minus 1. Now we need to check and make sure that this is the partial fractions decomposition of our original expression. Now that we've found our partial fractions decomposition of the original equation, let's now check that this is the partial fraction decomposition of our equation. So we'll start with our partial fraction decomp, and here we'll first get common denominators in each of our 3 terms. From here, now that we have common denominators in each of our 3 terms, we can write our expression as one fraction. From here, we can expand each of the 3 terms in our numerator, which leaves us with this line, and we can factor an 8 out from 16x minus 8, we can factor an 8 out from 16x plus 8, and we can factor a 2 out from 8x squared plus 2. Now in the numerator, some canceling will happen. Here we have 128x cubed plus 128x cubed is 256x cubed, and then minus 256x cubed. So these 3 terms will cancel. We have a 32x plus a 32x plus a 64x. This is equal to 128x. We have a 64x squared minus a 64x squared, which is 0, minus 128x squared plus 128x squared, which again is 0. So our numerator is not going to have an x squared term in it. Finally, we have a 16 minus 16. So our numerator is just 128x, and our denominator, well, 128 comes from 8 times 2, and 16x to the fourth minus 1 comes from 2x minus 1 times 2x plus 1 times 4x squared plus 1. Here, we have a 128 in the numerator and in the denominator, so we can cancel these 128s, and what we're left with is x divided by 16 times x to the fourth minus 1, which we see is equal to our original expression. Thank you.